Okay, you guys, today is the day that Trig identities become of use to us. So all of this torture before spring break, it will all make sense now. We're going to use trig identities to solve equations. Okay, so the first thing that I'm going to do is first of all, let me back up. You need to write down these three identities because they're going to be super important in solving equations. The Pythagorean identity, sine squared plus cosine squared equals 1. That list that I gave you before spring break, if you have that, you might want to pull that out too. Cosine 2 theta equals cosine squared theta minus sine squared theta. And sine 2 theta equals 2 sine theta cosine theta. So if I'm looking up here, I want to get everything into terms of cosine, because having a sine and a cosine, that makes it really difficult to factor or solve or do anything with it. So I'm going to subtract sine squared to this side. So I have cosine squared theta minus cosine theta plus 1 minus sine squared theta. And the reason I did that was kind of thinking ahead. The Pythagorean identity, if I subtract sine squared theta from both sides, 1 minus sine squared theta is going to be cosine squared theta, which is super handy because then everything is in terms of cosine. So right here, that turns into cosine squared theta. I've got cosine theta plus 1, and then here's cosine squared theta again. So I've got 2 cosine squared thetas. So 2 cosine squared theta minus cosine theta equals 0. And so from here I look at it and I'm like, oh, I don't know what to do. So what I'm going to do is go ahead and factor it because they both have cosine in them. So cosine, when I divide this one by cosine, I'm left with 2 cosine theta. Whenever I divide cosine by cosine, I get 1 equals 0. Then I'm going to set each part equal to 0. So cosine theta equals 0. Make my quadrant unit circle. I've got 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And if I look, cosine are my x values. So I go around right here. Is an x value of 0. I'm only going between 0 and pi over 2, which pi over 2, if you remember, is 90 degrees. So actually I have to stop right there. 90 degrees is one answer, or since it's in radians, pi over 2. Remember, it's 0, pi over 2, pi, 3 pi over 2. So pi over 2 or 90 degrees, that's one answer. So I'm going to go ahead and write pi over 2. That comes from that one. Now I'm going to do 2 cosine theta minus 1 equals 0. So I'm going to isolate cosine, add 1, 2 cosine theta equals 1, divided by 2. Cosine theta equals 1/2. So from here, I need to look and see where cosine is 1/2. I feel like we've done this one just a minute ago. So cosine theta, actually for you guys a couple days ago, think about which triangle it would be. So 1 and a 2, it'd be 30, 60, 90. So cosine is adjacent over hypotenuse. So adjacent's 1, hypotenuse is 2. This would be 60 degrees because it's across from root 3. So 60 degrees is one answer. And my other answer, go ahead and put it down here. All students take calculus. Cosine is positive in the 4th quadrant. So 1/2 adjacent over hypotenuse, and then root 3, negative root 3. This is 60 degrees again. We go around the circle, we're just shy 60 degrees, so it's 300 degrees as our answer from that line. We need to convert them both to radians since this is in radians, and actually, oops, I didn't need the 300 degrees because that's outside of our interval. So it's always good to save yourself work and look at that interval. But the 60 degrees is before 90. So 60 degrees times pi over 180. They're both divisible by 6. So 6 divided by 6 is 1, so pi. 18 divided by 6 is 3, so pi over 3 is our second answer. So our two answers are pi over 2 and pi over 3. So pi over 3 and pi over 2. And we did it! We're going to try a couple more examples.